Hey kiddos, today we are going to be moving on to midpoint, okay? Hopefully we remember, okay, midpoint is basically a point that splits a segment into two congruent segments, okay? We do have a specific formula that we do use for midpoint. X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2, okay? So notice we end up getting a point, which is what we're looking for, okay? A segment bisector, so another little vocabulary word I'm throwing at you, okay, is a point, ray, line segment, or plane that intersects the segment at its midpoint, okay? A midpoint or segment bisector bisects a segment. So in other words, what you really need to make sure that you understand is that this word here, bisects, means to, it basically creates two congruent pieces, okay? It splits something into two congruent pieces, essentially. So as you can see also, I'm not sure if you guys have been recognizing this, but this symbol here, this little dash mark, is telling you that AM and MB are in fact congruent. Now you can also see, instead of one dash mark, you can see two dash marks, three dash marks, so on and so forth. If they match up, then that means that they are the same, okay? All right, so example 1, finding segment lengths. In the skateboard design, I know, very fancy here, we have VW bisects XY. Bisects XY. So VW is bisecting XY at the point T. So we then know that XT, X to T, is 39.9. The question is, find what XY is. All right, well, let's use some of our knowledge here of bisecting. Hopefully we recall that bisects means it creates two congruent pieces. So notice I have marked XT with one dash. So therefore, TY should have one dash. What that means then is if XT is 39.9, then TY is also 39.9. So in order to figure out what XY is, all we have to do is take 39.9 and add it to 39.9, or you could have multiplied, whichever floats your boat. And we would get 79.8. So XY is 79.8 units length, which actually they do tell me the units. Sorry, just noticed that. It is centimeters. Yay. All right, example 2. MT, so ray MT bisects line segment PQ at point M. Okay, remember bisects creates two congruent pieces. And PM is 1.8 millimeters. Find PQ. So we're looking for the whole thing. Well, if we know that PM is 1.8, then hopefully we understand that MQ has to also be 1.8. So if we add those together, so 1.8 plus 1.8, we get a grand total of 3.6 millimeters to be the measurement of PQ. I know this is hopefully pretty simple. All right, example 3. Same exact concept, but gonna, make it a little bit more complicated. It's not just plain numbers. We got actual algebraic expressions here. So point M is the midpoint of segment AB. Find the length of AB. So they want us to figure out what is the whole length of this segment. Show all work, okay? So what we're going to do is, because we know that AM is congruent to MB because M is the midpoint, then we can actually set both of these equal to each other. So 3x minus 4 equals 2x plus 1 because they're supposed to be the same. They're equal to one another. So basically, we're just having to solve here. So I'm going to subtract 2x from both sides because it's always easier to move the smaller term with the x. 3x minus 2x gives you 1x. Bring down the minus 4 equals, they canceled out, and I bring down the 1. Box around my variable, doing the opposite by adding 4 to both sides. Those cancel out, and we get that x equals 1 plus 4 is 5. Now, please do not tell me that is your answer, because you're not listening to the question here. It says, what is the length of AB? So that means I actually have to plug it back in. I'm going to look at the 3x minus 4. I just picked one, and I'm going to plug this in. So we get 3 times 5 minus 4. 3 times 5 is 15 minus 4 is 11. So if A to M is 11, then therefore M to B has to also be 11. And if we add those together, 11 plus 11 gives us 22 units. Since they didn't specify. Yay! And we're moving on. All right, example 4. Same concept. Identify the segment bisector of segment RS, then find RS. Show all work. So essentially, what line is bisecting our segment RS? Hopefully, you identified it as line N. Okay, line N is bisecting segment RS. Now that we know that R to M is 4x plus 3, M to S is 6x minus 12, and these two pieces are congruent to each other. So again, just like the previous problem, if they're congruent, then we can set them equal to one another. So let's solve. I'm going to subtract the 4x this time because I like to move the smaller value. They cancel out on the left side. I bring down my 3, bring down my equal sign. 6x minus 4x is 2x, and I also bring down that minus 12. All right, now we're solving for x. Box around my variable. We cancel that negative 12 by adding 12. I'm sorry if I sound so elementary, but it's all gravy. Bear with me. 3 plus 12 is 15 equals 2x because those canceled out. We're going to divide both sides by 2, divide by 2, and we get that x equals, technically can't reduce that fraction, 15 over 2, but in this case, because we're going to have to substitute that in, I'm actually going to put my answer down as a decimal. I'm going to totally accept that, okay? So we're going to say x is 7.5. So 15 divided by 2 is 7.5, okay? So notice, I hope you do not think you are done because that is not the answer. That is not the question, okay? Please make sure that you guys are paying attention to the question when you're reading. We actually need to figure out what RS is. So I'm just going to plug in x into one of these segments. I'm going to take the 4x plus 3. So instead, when I substitute in, you get 4 times 7.5 plus 3. And 7.5 times 4 is 30 plus 3 gives us a grand total of 33. So we know that R to M is 33. So therefore, M to S must also be 33. And if we just add those together, we get a grand total of, whoops, I wasn't supposed to move that whole thing, but the little square is not moving, so I'm just going to do that, is 66. Sorry about that. Fail, epic fail. All right, example 5. Finding the midpoint. Now we're going to be using our midpoint formula. So the endpoints of segment RS are that R, point R here, is 1, negative 3, and point S is 4, 2. Find the coordinates of the midpoint M. So if I were to draw this picture, essentially, it would look something like this. RS and a beautiful M in the middle. And guess what? To make sure I know the M's the midpoint, I got to have some type of marking. Okay? That shows they're congruent. M is the midpoint. Awesomeness. Now, notice I have rewritten my 2 points, and I have labeled them. I've picked R to be the first point, x1, y1. I've picked S to be the second point, x2, y2. Now all we have to do is plug it into our formula. So the very beginning, and you guys should know this, x always comes first, y is always second. Easy way to remember this formula, because I do expect you to have it memorized. After all, you are honors students. So plugging in x1, which is 1, x2, which is negative 3. Second part, plugging in y1. Sorry, I just totally messed that up. That's not x. Why didn't you warn me? That's supposed to be a 4. Silly me. My bad. Yeah, now y1, negative 3, and y2, 2. My bad. So now let us break this down and simplify. 1 plus 4 is 5 over 2, comma. Negative 3 plus 2 is going to be a negative 1 over 2, half. And I want actually both answers if you end up getting a fraction, because if we're actually graphing this on a legit plane, on a coordinate graph, it's really hard to try and graph 5 over 2, okay? So it's easier to understand 5 over 2 if I tell you it is 2.5 or 2.5, personally, okay? So 2.5, comma, negative 0.5. So I actually want you guys to write both answers in fraction form and in decimal form. All right, so that is our midpoint. So I'm just going to draw a pretty little arrow here, because this is what should have gone there. Again, another similar problem. The endpoints of line segment CD. So I have a segment, CD, point M is in the middle, marking. That's how you know they're congruent, okay? And we have those 2 points written down here already. So I have point C and I have point D. And we're having to use our midpoint formula to figure out what the midpoint, is. Whew. So I've labeled point C as my x1, y1, point D as my x2, y2. So remember the formula, very first value is x. So x1, negative 4, x2, negative 6. Then the second part, we have y1, 3, y2, 5. All right, let's see what we get when we break this down. Negative 4 plus negative 6 gives us a negative 10 divided by 2, comma. 3 plus 5 is 8 over 2. If I'm not mistaken, this is going to reduce. Negative 5 divided by 2, negative 5. I just give the answer. Negative 10 divided by 2 is negative 5. OMG. And 8 divided by 2 is 4. So our midpoint is negative 5, comma, 4. All right, so this one we're going to be working a little bit backwards-ish, because they're actually giving us the midpoint, okay? So they're telling us that the midpoint of line segment JK is 2, 1. So they're giving me the midpoint. One endpoint, though, J, is 1, 4. Find the coordinates for endpoint K. So we're still going to utilize our formula here, but the nice part is we're actually going to put what the midpoint is. Notice our midpoint is actually going to be not that necessarily, because our midpoint is an actual point, okay? So it does have its own x and y values. So let's plug in what we know. Notice I went ahead and I labeled J as my first point, so x1, y1. So I know x1 would go here, and y1 would go here. And our midpoint, our actual answer, is this, what they gave us, and that's 2, 1. Now here's the neat part. You can actually separate this into 2 equations, okay? We know that this is going to deal with our x value. So 1 plus x divided by 2 is going to equal 2. So let's just do that first. So I'm just going to break it apart. 1 plus x divided by 2 is equal to 2. All right, so all I did was bring this down, and I made it equal to the x value in the midpoint. Okay, that's all I did. So let's go ahead and work this out. You cannot have it divided by 2, so we got to do the opposite, and let's multiply both sides by 2. That cancels out. We get 1 plus x equals 4. All right, so where am I? All right, box around our variable, subtract 1 to both sides, and I'm going to write it off here to the side. X equals, that canceled out. 4 minus 1 is 3. So far, we got k to have a value of 3 for the x. Now to do the y value. So now I'm going to take out the y portion, which is the 4 plus y divided by 2. And that's going to be equal to the y value of our midpoint, which is 1. All right, so same concept. Can't have a 2 in the bottom divided by 2, so I got to do the opposite. I'm going to multiply both sides by 2. And we get that canceled out. You bring down 4 plus y equals 2. Solving for y now, so I'm going to subtract 4 to both sides. So you end up with y, because those canceled out, equals 2 minus 4, negative 2. So we get k to be 3, negative 2. All right, you knew it was coming. Of course. I leave it for the very end. Sometimes I will, sometimes I won't. You just never know. That's the fun of it all. So you have this example to do on your own. And yes, it is one where you are given the midpoint. So it's just like the previous problem I just did, okay? So be sure to make sure that you write your formula out, okay? That you identify your x1, y1, and that you set those individual pieces equal to what the midpoint values are of them and solve. If not, be sure to pause, go back to example 8, review it, and try example 9 again. And no worries, if you still don't get it, when you come to class, be prepared with your questions to ask me. Word. Adios.